Namaskar, dear students, welcome. So far, we have done 26 classes on differential equation of first order and first degree. From today, we shall solve all problems from the book Shipley L. Rose. Shipley L. Rose. All problems from this. This is your textbook. From your textbook, all problems from the exercise will be done here in these YouTube classes. Now, let us try to solve this problem. Let us start from the book Shipley L. Rose. Solve this question. 2.1, section 2.1. In your textbook, you will find this one. From 2.1, we shall solve this. Now, this is an exact differential equation. We discussed that a differential equation of the form m dx plus m dy equal to 0, where m is a function of x and y, also n is also a function of x and y. This differential equation is said to be exact if there exists a function u of xy such that this mxy m dx plus m dy such that m dy this is equal to d of u. Then such type of differential equation is said to be exact. If you can find a function u of x and y such that m dx plus m dy can be written as this. This means that you have found this is equal to du xy. Du equal to 0. Then if you integrate it, u equal to constant. This is the solution of the exact differential equation. This will be the solution of the exact differential equation. Now, we shall solve this problem in three different ways. An exact differential equation can be solved in three different ways, and all the three problems will be discussed. Now, if you compare this differential equation, just compare this differential equation with, suppose this is number 1. Comparing 1 with m dx plus m dy, m xy dx plus m plus m xy dy equal to 0, we get m equal to m xy equal to this one, twice x sin y plus y cube e to the power x, and this will be equal to x square cos x cos y plus thrice y square e to the power x. Now, del m by del y, you know that m dx plus m dy equal to 0 will be exact differential equation if del m by del y equal to del n by del x. If del m by del y equal to del n by del x. Del m by del y, with respect, just differentiate it with respect to y, treating x as constant. Then you will find del y of twice x sin y plus y cube e to the power x. This is equal to twice x cos y plus thrice y square e to the power x. Similarly, del n by del x, with respect to x, you will get twice x cos y. Treat y as constant, you will get thrice y square e to the power x. Now, see, twice x cos y plus thrice y square e to the power x. Twice x cos y plus thrice. This means that This differential equation 1 is exact. This means that the differential equation 1 is exact. Therefore, del m by del y equal to del n by del x. Therefore, 1 is exact. 1 is exact. 1 is exact. Now you see, 1 is exact. This means that there exists a function u of xy such that du equal to 0. Such that du equal to 0. du is equal to 0. du equal to 0. U is a function of x and y. This means that del u by del x dx plus del u by del y dy equal to 0. This means this. It clearly indicates that del u by del x should be equal to m and del u by del y, this should be equal to m. Del u by del x equal to del u by del x, this should be equal to m and del u by del y equal to m. This means that therefore 1 is exact. Therefore, there exists a function u of xy such that du equal to 0. Such that du equal to 0. du equal to 0. This means del u by del x dx plus del u by del y dy equal to 0. This is equal to 0. This will be equal to 0. This clearly indicates that del u by del x equal to m and m means mxy. I am meaning mxy means we shall write m. It is a function of x and y. We will simply write m. Del u by del y, this is equal to m. Del u by del x equal to m. Del u by del y equal to m. We will get this one. Therefore, del u by del x equal to m means twice x cos y plus twice x sin y plus y cube e to the power x plus y cube e to the power x. You will get this. And del u by del y, just you may del u by del y, x square cos y plus thrice y square e to the power x. X square cos y plus thrice y square e to the power x. X square cos y plus thrice y square e to the power x. This is method 1. Del u by del x equal to this, del u by del y will be equal to this. Now, this means u means a function of xy will be equal to integral twice x sin y plus y cube e to the power x, this del x, plus a simple a function of y, plus a function of y. Because if you If you differentiate this with respect to x partially, then you will get this one. If you differentiate phi y partially with respect to x, it will be equal to 0. This is constant when you are integrating with respect to x. Now integrate dx, treating y as constant. Treating y as constant, then you will get x square sine y. Treating y as constant, y cube e to the power x plus phi y. You will get this one. U xy will be equal to this. U xy will be equal to x square sine y plus y cube e to the power x plus fy. U is equal to this. Now del u by del y. This means del u by del y. What will be del u by del y? Del u by del y will be equal to, if you integrate this one with respect to y, del u by del y, you will get x square cos y plus thrice y square e to the power x plus d dy of phi y. You will get this one. You will get this one. But this should be equal to n, which is equal to n. But del u by del y equal to n. Therefore, x square cos y plus thrice y square e to the power x plus d phi by dy equal to n. This is equal to n. What is n? N is equal to del u by del y equal to n. Will be equal to n. N is equal to this, x square cos y plus thrice y square e to the power x. Now this means that from this, these two terms will be cancelled. d phi by dy equal to 0. This means phi equal to constant. This means phi y, this is y, a function of y, equal to constant. C naught equal to constant. Phi y equal to constant. Phi y equal to constant. You will get this. Therefore, u xy equal to, from this, suppose this is star, from y. Therefore, from y, therefore u xy, this is equal to x square sine y plus y cube e to the power x phi y equal to c naught. Phi y is equal to c naught. Now, the differential equation is exact. Means m dx plus m dy equal to 0 is an exact differential equation. Means we shall we can find a function u of x or y such that m dx plus m dy is equal to du. This means that du equal to 0. M dx plus m dy equal to 0 means du equal to 0. Means u is equal to constant. U is equal to constant is the solution of the differential equation. Solution of the differential equation is, solution of the exact differential equation is, solution of the exact differential equation is u xy equal to constant c1. U xy equal to c1. Exact differential equation is u xy equal to c1. Therefore, x square sine y plus y cube e to the power x plus c naught equal to c1, or x square sin y plus y cube e to the power x equal to c1 minus c0, or x square sin y plus y cube e to the power x equal to c, where c equal to c1 minus c0. In this way, we can solve the differential equation. This is the method. This is method 1. Now, let us come to solve the differential equation by method 2. This is the differential equation. We shall solve this differential equation by method 2. Since the differential equation is exact, this is m, this is n. This is m, this is n. Del m by del x, del m by del y equal to del n by del x. Therefore, this is exact differential equation. The solution is integral m dx, treating y as constant, plus integral m dy, taking only those terms in n which are free from x, which do not contain x. So you may write which do not contain x. Which do not contain x. This is equal to constant. Therefore, here treating y as constant, twice x sin y plus y cube e to the power x dx, plus treating y as constant, which do not integral m dy, taking only those terms which do not contain x. This term अब देखिए, it contains x. This term also contains x. Therefore, it will be 0, equal to constant. Now, integrate this, treating y as constant. Integrate this, treating y as constant. This means y as constant, it will be x square. Treat sin y as constant, x square sin y. Treating y as constant, it will be y cube e to the power x equal to c. Y cube e to the power x is equal to c. This is the solution of the differential equation. In the previous way, you see x square sin y plus y cube e to the power x equal to constant. X square sin y plus y cube e to the power x equal to constant. This is method 2. We have already discussed in previous classes. Now, let us try to solve this problem by using method 3. By grouping method, we shall solve this equation by grouping method. Since the equation is exact, therefore, it can be expressed in the form du equal to 0. Means these terms can be expressed in the form d of some functions of x and y equal to 0. D of some functions of x and y equal to 0. Therefore, you may write here twice x sin y dx, plus x square cos y dy, plus y cube e to the power x dx, plus thrice y square e to the power x dy equal to 0. This is equal to 0. This means sin y twice x dx plus x square cos y dy plus y cube e to the power x dx plus e to the power x thrice y square dy. This is equal to 0. This is equal to 0. This means sin y d of x square plus x square. This is, you may write like this. These are two groups. X square cos y dy can be written as this one plus y cube d of e to the power x plus e to the power x d of y cube. This is equal to 0. This is equal to 0. Now, this means here first function differentiation of the second function plus second function differentiation of the first function d of x square sin y plus here d of e to the power x y cube. This is equal to 0, or you may write d of x square sin y plus e to the power x y cube equal to 0. Integrating we get x square sin y plus e to the power x y cube equal to constant. This is, in this way also we can solve the differential equation. Now you see x square sin y plus y cube e to the power x. Here also x square sin y plus e to the power x y cube. Therefore, we have solved this differential equation, this exact differential equations in 3 different ways. Let us try to solve another problem. Let us try to solve this problem. Compare this equation with m dx plus m dy equal to 0. Here m xy equal to thrice x square plus 4xy, m equal to twice x square plus twice y, del m by del y equal to, with respect to y, treating x as constant, it will be 0 and it will be 4x. Del m by del x with respect to x, twice x square, it will be 4x and twice y, that will be equal to 0. Therefore, del m by del y equal to del n by del x. Del m by del y equal to del n by del x. Therefore, suppose this is number 1. Therefore, 1 is exact. The given differential equation 1 is exact. Therefore, the given differential equation 1 is exact. Now, since it is exact, there exists a function. Since 1 is exact, there exists a function. Suppose suppose this is f of xy, such that df xy should be equal to 0. This means del f by del x dx, this is xy, dx plus del f by del y dy equal to 0. This means that del f by del x should be equal to m, del f by del y equal to m. Therefore, del f by del x should be equal to thrice x square plus 4xy, m del f by del y. It is of course a function of x and y. You may write simply del f by del x. Del f by this is equal to twice x square plus twice y. X square plus twice y. You will get this one. This means from this f of xy will be equal to 3x square plus 4xy integrate treating y as constant plus pi y treating y as constant pi y. This is equal to x cube. This will be equal to x cube with respect to x partially integrate. Now y is constant, twice x square y plus pi y means f of xy equal to this. F of xy equal to this. Now f of xy equal to this. Now del f by del y. What will be del f by del y? Del f by del y. What will be del f by del y? With respect to y, it will be constant and twice x square plus d pi y by d with respect to y dy. This is equal to twice x square plus d pi y by dy. Now you will get this one. Now del f by del y, this is equal to m. What is m? N is equal to twice x square plus twice y. Therefore, twice x square plus d pi y by dy equal to twice x square plus twice y. This means d pi y by dy equal to, you will get twice y. This means pi y equal to y square plus a constant. Suppose this is a constant c naught. Therefore, from this, therefore pi. Therefore, the function f of xy equal to x cube plus twice x square y plus pi y means y square plus c naught. Therefore, solution, since the differential equation is exact, therefore there exists a function f of xy such that d of xy equal to 0 means the solution is f of xy equal to constant. Solution of the exact differential equation is solution of one is f of xy equal to constant. Suppose c1. Solution of one is f of constant equal to c1. Therefore, x cube plus twice x square y plus y square plus c naught equal to c1. This means x cube plus twice x square y plus y square equal to c1 minus c0. This means x cube plus twice x square y plus y square is equal to c. This is the solution of the differential equation. We can solve this equation in this way. Now, let us try to solve this problem in another way. Now, solve this equation. Here it is m, this is n, this is n. Solution is integral m dx treating y as constant. y as constant, plus integral m dy, taking only those terms in n which do not contain x equal to constant. This is equal to constant. Therefore, this means integral m dx thrice x square plus 4xy dx plus integral m dy, taking this term में x है, this term में नहीं है, इसको ले लेना है, twice dy equal to constant c. This means the equation solution is integration of this is this. What is the integration? Taking y as constant, 4 into x square by 2. This means twice x square y plus it is y square equal to c. This is the solution of the differential equation. X cube plus twice x square y plus y square equal to c. Now let me solve this equation in another by grouping method. Method 3. Suppose method 3. Thrice x square plus 4xy dx plus twice x square plus twice y dy equal to 0 is exact. This differential equation is exact. It is given. Now group system. Grouping thrice x square, इस पे कोई y है ही नहीं, इसीलिए तो इसको इस तरीके से लिखना है, thrice x square dx plus 4xy dx plus dy का साथ पे twice x square है, इसीलिए twice x square dy, इसको ग्रुप बना दीजिए, plus twice y dy equal to 0. Now for this d of x cube प्लस इसमें तो y, इसमें एक काम कीजिए आप, इसमें एक काम करना पड़ेगा, दो कॉमन ले लीजिए, twice xy dx प्लस x square dy इस तरीके से लिखिए, प्लस इसको d of y square equal to 0 इस तरीके से लिखिए, प्लस इसमें क्या है, d of x cube प्लस 2 times of, इसमें आप एक काम कीजिए, d of twice x dx, for the timing twice x dx लिख लीजिए, प्लस x square dy plus x square dy plus d of y square, this is equal to 0. Now इसको ऊपर थोड़ा सा ऊपर लेके जाता हूं मैं, this means d of x cube plus 2 times of, इसमें d of x square लिख सकते हैं आप, twice x dx can be written as d of x square प्लस x square dy इस तरीके से लिखिए आप, प्लस d of y square equal to 0, this is equal to 0, Now this means d of x cube प्लस, इसको देख लीजिए, फर्स्ट फंक्शन डिफरेंशिएशन ऑफ द सेकंड फंक्शन प्लस सेकंड फंक्शन डिफरेंशिएशन ऑफ द फर्स्ट फंक्शन, d of x square y plus d of y square equal to 0. Right. This means d of x cube plus twice x square y plus y square equal to 0. So integrating x cube plus twice x square y plus y square equal to c. This is the solution of the differential equation. अब देखिए x cube plus twice x square y plus y square equal to c. Here also x cube plus twice x square y plus y square equal to c. We have solved these two problems in 3 different ways. All the problems have been done in 3 different ways. Now let us try to solve this problem. इसको देख लीजिएगा, इस प्रॉब्लम में आप देखिए, हियर m equal to, m means m of xy equal to twice x cos y plus thrice x square y, and n equal to x cube minus x square sin y minus y, del m by del y. Now del m by del y with respect to y, treating x as constant, it will be twice x minus twice x sin y minus twice x sin y. With respect to y, it will be thrice x square, and del n by here, del n by del x, it will be thrice x square minus, it will be twice x, it will be twice x with respect to x sin y. With respect to x, it will be 0. Therefore, you see, plus thrice x square plus thrice x square minus twice x sin y minus twice x sin y. Therefore del m by del y, del m by del y equal to del n by del x, del n by del x. Therefore, suppose this is number 1. Suppose this is number 1. Therefore, 1 is exact. Therefore, 1 is exact. Therefore, 1 is exact. Exact differential equation. One is exact differential equation. Now, therefore, therefore there exists a function f xy such that del f by del x equal to m, del and del f by del y equal to m. This means equal to m. This means del f by del x, f means a function of xy, mind this, equal to m. M means twice x cos y plus thrice x square y plus thrice x square y plus thrice x square y. You'll get this one. And del f by del y, del f by del y equal to n. What is n? N is equal to x cube minus x square sin y minus y. Del f by del y equal to this. We shall find this. Now, from this, you will get this one. Okay. This means f of xy equal to integral twice x cos y plus thrice x square y del x plus this will be equal to phi y, which is equal to integrate this treating y as constant. It will be x square cos y plus x cube y plus phi y. This is f of xy equal to this. Actually, solution is this. Now we have to find solution is f of xy equal to 0 constant, and in addition we have to find this phi y. We have to find this phi y. Suppose this is number star. Now Del f by del y. What is del f by del y? From this del f by del y with respect to y, you will get minus x square sine y, minus x square sine y plus x cube plus d phi by dy. D phi by dy. You will get this. Now, d phi by dy equal to this. Del f by del y should be equal to m. Now, del f by del y should be equal to m. This means minus x square sine y plus x cube plus d phi by dy equal to m. M means x cube minus x square sine y minus y. This means d phi by dy equal to minus y. This means phi equal to minus y square divided by 2. Phi is equal to minus y square divided by 2. Phi y means phi y. This means this means phi y equal to minus y square divided by 2. Therefore, star implies f of xy, this is equal to x square cos y plus x cube y minus y square by 2. Minus y square by 2. Therefore, solution of one is solution of one is f of xy equal to constant f of x minus y square by 2 plus you may write here c naught plus c naught equal to constant. This means which is equal to c1, say x square cos y plus x cube y minus y square by 2 plus c naught equal to c1. This means x square cos y plus x cube y minus y square by 2 equal to c1 minus c0. Or x square cos y plus x cube y minus y square divided by 2 equal to c, where c is equal to c1 minus c0, where c is equal to c1 minus c0. C equal to c1 minus c0. This is the solution of the given differential equation. This is the solution. But you see here, now you see, what is this here? And my God, the solution of the differential equation is this. This is the solution of the differential equation. X square cos y plus x cube, this one. This is the solution of the given differential equation. This is the solution of the given differential equation. Now, y0, it is also given that y0 equal to 2. This is given. Y0, this is equal to 2. Y0 equal to 2. Given that y0 is equal to 2. Right? Given that y0 equal to 2. Therefore, from this Therefore, put x is equal to 0, y is equal to 2. 0 cos 2 plus 0 2 minus 2 square divided by 2 equal to c. This means c is equal to minus 2. Therefore, solution is, therefore complete solution is therefore solution is x square cos y plus x cube y minus y square by 2 equal to minus 2. This is the solution of the given differential equation. X cube cos y plus x square cos y plus x cube y minus y square by 2 equal to minus 2. This is the solution of the given differential equation. Now, let me solve this problem in another way. In this way. Suppose grouping system. Now solve this equation by grouping system. This means twice x cos y dx, twice x cos y dx plus, not plus, take this one, minus x square sin y, x square sin y dy plus thrice x square y dx plus x cube dy, thus group minus y dy equal to 0. This is equal to 0. Or cos y, for this you may write d of x square minus x square, for this you may write d of cos y, since cos y equal to minus sin y dy, you may write like this, plus y thrice x square dx can be written as d of x cube plus x cube dy minus d of it, you can write y square by 2 equal to 0. Or for this bracket you may write first function differentiation of the second function differentiation of the first function. You may write cos square x square cos y plus d of x cube y minus d of y square by 2 equal to 0. Or d of x square cos y plus x cube y minus y square by 2 equal to 0. Integrating you may write x square cos y plus x cube y minus y square by 2 equal to c. This is equal to c. Now, given y0 equal to 2, this means 0 into cos 2 plus 0 cube into 2 minus 2 square by 2 equal to c. This means c is equal to minus 2. Therefore, from this you will get x cube, no, not x cube, from this x square cos y plus x cube y minus y square by 2 equal to minus 2. You will get this one. This is the solution of the given differential equation. Now, we have solved this equation in this method also. Now, solve this equation in this method. we have solved this equation in this method. Now you see here, let us try to solve this equation in the third method. What is the third method? Suppose the integration solution is integrate solution is integrate m dx treating y as constant plus treating y as constant plus integrate m dy taking only those terms which are free from x which are free from x equal to constant. This means treating now twice x cos y plus thrice x square y dx plus from here taking only those terms which do not contain x or taking which are free from x. This is not free from x, this is not free from x, only this term is free from x equal to constant. This is equal to constant. Now this is equal to constant. Now you see here this means with respect to x treating y as constant, it will be x square cos y plus it will be x cube y, it will be minus y square by 2 equal to c. Suppose this is number a, now this is number a. Also given that, now given that y0 equal to 2, this means from this 0 into cos 2 plus 0 into 2 minus 2 square by 2 equal to c. This means c is equal to minus 2. This means c is equal to minus 2. C is equal to minus 2. Therefore, c is equal to minus 2. C is equal to minus 2. Now, A implies x square cos y plus x cube y minus y square by 2 equal to minus 2. This is the solution of the given differential equation. Therefore, we have solved three problems in three different methods. Total in practical, we have done 9 problems. We have solved 3 problems in 3 different methods. Therefore, in practical, we have done 9 problems. Therefore, in the next class, we shall solve problems from the chapter, from the exercise 2.1 of Shipley L. Rose, from the book Shipley L. Rose. All problems will be solved. Therefore, I want to stop here. Thanks for attending the class. Thank you very much. बहुत बहुत धन्यवाद. नमस्कार.